14 minutes, so that's still good. We're still on track, 7 minutes for each person, so looking
Basically,
good.
my question was, what ray of the light spectrum was the hottest? And so my hypothesis was that anything red or beyond would be the hottest because the darker the color gets, the more heat it absorbs. So if it absorbs more heat, it'll be hotter. So yeah, and my results, well, my results were that the first time, so I tried both of them 2 times. Red, beyond red was 80 the first time, and then the second time it was 83. And yellow was 80.5 the first time, and 81 the second time. And blue was 80.1 the first time, and 81.5 the second time. So essentially my hypothesis was correct because beyond red was the hottest. The reason I didn't put it like that was because red and beyond, they were all the same heat, so I decided it'd be better if I just put in one section beyond red. So yeah.
Let's hold on, because we don't know if it's done yet.
And my research was, so infrared energy is a form of radiation that can be found below visible light. Even though infrared energy cannot be seen, it still produces heat. Infrared energy was discovered in the 1800s when an astronomer named William Herschel conducted an experiment where he placed thermometers underneath each color of the visible spectrum. When he noticed that the ray emitted most heat was not visible, and he discovered infrared rays. An example of infrared rays is if you were to take, if you were to look at a thermal camera, it detects infrared rays that particular objects emit. Other ways that infrared energy is used in modern day life are in TV remotes, infrared lamps, and astronomy, looking at faraway planets, nebula, stars, and other space-oriented things. Body.
I don't know, but do you think how old the marker or paint would be for the effect?
What?
Like how old?
I used so basically what the materials were a glass prism, 3 alcohol thermometers, and then all the other stuff was for the board and stuff. So really, so when the sun was shining, it went through a glass prism, and then there were thermometers to measure how hot each color. So it basically, so you know when light goes through a glass prism, it creates like a rainbow. So then you measure how the heat of all the colors on the rainbow thing, and then you see which one is the hottest because the thermometers rise the heat, and that's how you measure.
Do you think the time of day?
Well, yes, because if it's a sunny day and it's the afternoon,
Goes over the sun.
yeah, and if it's a sunny day and it's in the afternoon, it will usually be hotter in the afternoon if it's the day is always sunny. So. Brian?
Why did you pick this?
Well, it kind of just popped up in my mind. Which color of the rainbow is the hottest? And so I decided. Lucy?
Well, for the experiment, would there be a variable, if maybe a little bit of the heat was still left over from, if you took the thermometer and put it in places, well, maybe a little bit of the
We reset the thermometers.
Oh,
Maybe.
What do you think it would change the results if the glass prism's size was different?
I don't think so, because that would only make the rainbow bigger, and that really wouldn't make a difference. Well,
Because
the
there's
fact
more
that
size of the lights.
it could absorb more heat. So I guess it could, because if it's bigger and it's a darker color, it could absorb more heat. And I don't know.
It's a good question.
Emery.
Would the temperature of the room also change?
It was outside.
Oh. Or the temperature outside?
Well, the project didn't take very long to conduct each project because it was, you put it down, you set up where the glass prism was going to be, it shined down on the thermometers, and that's it. So I don't think the thermometers would really have enough time to heat up from the sunlight. Brian?
Why did you specifically did it in the afternoon, not like?
Well, because I realized, actually, I don't know. Well, it's probably because I had a soccer game that morning that I did it. So when I came back, I did it immediately. So that's probably why. But yeah.
One more question.
So
If you could verify your project, how would you verify it? Like, if you ask your parents to take pictures and do it for you in the morning or something, then the day and the afternoon you change it, like change your technology.
if I conducted the experiment 3 times, once in the morning, once in the afternoon, and once in the evening.
No, I'm asking how would you change it?
How would I
If you could, the experiment. That was an example.
I don't understand.
If you could redo the experiment, how would you change it to make it better?
I would probably, I'd probably conduct it more times it changed a lot when I conducted it 2 times, like by 2 degrees, like minimum of 2 degrees or 0.5 is minimum and 2 degrees is the maximum. So I'd probably conduct the experiment 5 or 10 times to see how many times it'd get the same results and how many times it would vary, and how large it would be to vary. Like if I had 80 and then 85 on another one, how many times it would be a lot and it would be the same, and how many times it would be very little.
Good question. Great responses, Armin. You know your subject. So we have about 5 minutes for Elise. Think you can do that, Elise? Well done. Do we give him a round of applause? If you want to take a mocha, you're more than welcome to. It's up to you.
So the title of my experiment is What is it? Heat. My purpose for the experiment is to find out what is better for transferring heat, copper, steel, or aluminum. My hypothesis is if I use copper, steel, and aluminum to transfer heat, then steel will work the best because I know that steel is the best conductor that I know of and heard of. Material, 6 paper cups, water, hot and cold, a copper rod, a steel rod, and a aluminum rod, a digital thermometer, and a black marker. And so my experiment is first mark 3 cups as cold and 3 as hot. Make a mark on all the cups with a black marker so we have an equal amount of water in each cup, both hot and cold. Make sure that each wire is the same length and then each wire like this, forming a bridge. Make some ice cold water and boil some water, making hot water. Pour ice in 3 cups and water and hot water in the other 3 cups. Record the temperature every 5 minutes for 30 minutes. So I have 2 graphs and a table. So they all started out the same in the very beginning. And what happened is that copper and aluminum stayed the same for a long period of time, which can be shown in my table and my graphs. And so the blue is copper, the orange is steel, the gray is aluminum. And the steel took its own little path to transfer the heat, and so after 10 to 15 minutes of the experiment, the aluminum stopped transferring heat as much as the copper did, and the copper just kept on transferring while the aluminum just stayed in the same range. The steel kept on transferring heat even after 10 to 15 minutes into the experiment, and so the conclusion is my hypothesis was proved incorrect. Copper proved to be the best for transferring heat. Although my hypothesis was incorrect, it was not the worst conductor either. Aluminum is the worst conductor because it stopped transferring heat after 10 to 15 minutes into the experiment. In conclusion, copper transfers heat the best. And you can see that copper's heat coldness has gone up and its warmness has gone down. The warmness has gone down and the coldness has gone up, and so is the aluminum, but the copper transferred the most than steel and
Questions for
Aiden?
So you had an equal amount of water in each cup, right?
Yeah.
So do you think the size of the cups and if you fill them up to like fully, then do you think it would make the results hotter or colder?
Well, I think that the results wouldn't change and that copper would stay the best, but I do think that they would all start out maybe with a different temperature, most likely, and end up with a different temperature at the end of the experiment. Ryan?
Why did you choose aluminum?
Aluminum because, well, we use aluminum foil a lot, and sometimes my lunch got cold afterwards. So I was wondering if maybe the aluminum would maybe transfer the heat to different places.
Yeah, good thinking. I see you with your aluminum foil.
Audie?
Do you think the density, like the way you folded and tested the
Most likely it would change experiment. Well, we had to do it because these weren't really the same width as the copper, and when we went to the store, they didn't really have it in the same size, any of them, so we just had to quickly do it. But it could have maybe changed a bit, but I'm not really sure because copper still proved to be the best, even though the way it folded.
No,
Yeah, I wonder.
wouldn't the density,
There's the density of what do you mean?
the density to make it go transfer faster?
So you mean like how it, I don't really, yeah.
Tough question. And how did you measure it, and where did you measure it?
Well, onto this is this little needle kind of thing, and we just put it in the water, then wrote it down, and we made a different graph and just wrote it all down and taped it up. So we just put it into the cup, first in that one, and we let it sit until we got one temperature, and it didn't move for a little while, then we write it down. That's what we
I
did.
was eating Maggi noodles once, and I was trying to see how hot it is, and so I kept touching the bowl, and it kept getting hotter and hotter, and then my mom told me that the heat is going into the bowl, and it's coming out of the noodles. And so, do you think that where you put the needle and like if it's touching the cup or just
Well, we just like put it, we didn't touch the metal part because there's also like a water, but we just put it in and just fold it and just wait.
I'm gonna have to cut off the questions, but we can always ask questions tomorrow because we are very late for car line, and I don't want anybody's car